Section 6.1 Two Variable Equations. In this section, we will start to explore solving equations that have two different variables in them. Because the equations have two different variables, there is more than one possible solution for the equation. But before we look at two variable equations, let's review an equation that has just one variable. If you are given the equation 2x plus 5 is equal to 13, there is only one possible answer for that particular equation. We can go through and solve that using algebra by getting the x all by itself on one side. In order to do that, we would just first of all subtract 5 from both sides, which would then give us on the left side 2x, and on the right side 13 subtract 5 would give us 8. After that, we would go through and divide both sides by 2, and that way on the left-hand side, the 2 divided by 2 would cancel out, leaving me just with x is equal to 4. In this equation, there is only one variable, and there is one possible answer for this equation. As I said, in this section though, we are going to talk about equations that have two variables. And here's an example. If you have the equation x plus y is equal to 5, I have two variables, and I'm calling them x and y. And there are all sorts of different answers that x and y could be. Whatever x is dependent upon what y is, and whatever y is dependent upon what x is. One way to start listing the different values is to set up a t-chart. So I'm going to set up a t-chart and put the column headings x and y up at the top. And I'm going to start putting in some values for x. If x is 0, then y is equal to 5, because 0 plus 5 is equal to 5. If x is 1, y is equal to 4. If x is 2, y is equal to 3. I could continue on in this pattern. If x is 3, y is equal to 2. Or I could say, if y is 1, then x is equal to 4. As you can see, there are an infinite number of possibilities for this, because I could certainly go into the negatives as well. If x is negative 1, then y is equal to 6. And I could also go into fractions. If x is 1/2, then y is equal to 4 1/2. There are all sorts of possible answers, and as I say, an infinite number of possible answers for this equation, not just one. Often, people put the answers to a two-variable equation in a t-chart, like I have here. But another way to list the answers is to put them into what we call ordered pair. We said that x is 0 and y is 5. So oftentimes people might write it just as this, in parentheses 0, 5. Or someone could put 2, 3. This is known as an ordered pair. And in an ordered pair, the first digit that is given is what the x answer is, and the second answer that is given is what the y answer is. And remember, the x answer is dependent upon the y answer, and the y answer is dependent upon the x answer. But as I say, this ordered pair is another way to write possible solutions for a two-variable equation. The equation that we just got done working with, x plus y equals 5, was a pretty easy equation to find different possible answers. So let's take a look at another equation that might not be quite so easy. If I have 2x plus 3y is equal to 26, let's say I wanted to say that x was equal to 4. If x was equal to 4, the question is, what does y equal? In order to find the answer to that question, what I need to do is I need to put 4 where the x is into the original equation and then solve it. So I'm going to go through and do that. 2 times 4 in place of the x plus 3y is equal to 26. In order to solve this, I'm going to solve this the way that I solved that very first equation when it was a one variable equation, and that at the very beginning of this video. I'm going to go through and multiply. 2 times 4 is 8. 8 plus 3y is equal to 26. I want to get the y all by itself, so I'm going to subtract 8 from both sides. And doing that means that on the left-hand side, I have 3y. On the right-hand side, 26 subtract 8 gives me 18. Then I'm going to divide both sides by 3, which then gives me a final answer. Because 3 divided by 3 cancel, I get y is equal to 6. So, if x is equal to 4, that must mean that y is equal to 6. So an ordered pair that satisfies this particular equation is the ordered pair 4, 6. Of course, there are other possibilities, other possible ordered pair that will also work, but that is one that will work for this equation. Here's another equation. 2x plus y is equal to 8. But this time, rather than being told what x is equal to and then trying to solve it for y, let's say that you are asked to find 4 different possible solutions for this. In order to do this, you can, if you want to, set up a t-chart and then eventually change that t-chart into ordered pairs. So I'm going to do that and set up a t-chart with x and y. If x would be equal to 0, that would eliminate the 2x in that equation. So then I would just have y is equal to 8. So one possible ordered pair for this is 0, 8. If x was equal to 1, and I'm just choosing any values that I want to, then if I want to go through and solve 2x plus y is equal to 8, and say y is equal to 1, if I did that, and that was equal to 1, I would have 2 plus y is equal to 8. So then y would have to equal 6 after subtracting 2 from both sides. So I would have 1 and 6 as another possible ordered pair for this. As I said, you can choose anything that you want to for these. I could skip 2 if I wanted to and try x is equal to 3. If I did that, I'm going to put 3 in for the x in my original equation. 2 times 3 plus y is equal to 8. And then 2 times 3 is 6, so I have 6 plus y is equal to 8. So then y would have to equal 2. So another possible solution would be the ordered pair 3, 2. Let me go through and try this time putting in a value for my y. If I said y was equal to 0, then I could go through and figure out what my x is. And once again, I'm going to go through and I'm going to write out the original equation. 2x plus y is equal to 8. But instead of putting in a y, I'm going to put in that 0. So here I have 2x plus 0 is equal to 8. Solving that, I'm just going to have 2x is equal to 8, and then dividing both sides by 2, I get an answer of x is equal to 4. So another ordered pair that would work would be the ordered pair 4, 0. Here I have 4 different possible answers for this two-variable equation. But remember, there's an infinite number of different possibilities. As you are doing the homework in this section, you'll be asked at times to come up with perhaps up to 4 different possible solutions. Just remember that the 4 possible solutions that you give may be different than the ones in the answer key in the book. Here's another example, but my equation looks a little bit different. Y equals 2x minus 5. In this equation, I don't have the x and the y on the same side of the equal sign as I've had in the past, but I can still go through and solve this in the same way. I'm going to set up a t-chart for this again, and then eventually change the t-chart answers into ordered pair. And once again, I can just start choosing any values that I want to for x. I'm going to choose 0 and put a 0 in where the x is. If that's the case, when I go through and solve this, I'm going to have y is equal to 2 times 0 minus 5. If I want to simplify this now and figure out what y is, 2 times 0 is 0, so y is equal to 0 minus 5, or y is equal to a negative 5. So, one possible set of values is 0, negative 5. If I want to come up with another answer, let's let x equal 1. So I'm going to put 1 in. So y is equal to 2 times 1 subtract 5. If I want to solve this and find out what y is, 2 times 1 is 2. I have 2 subtract 5. So this time y is equal to a negative 3. So this ordered pair would be the ordered pair 1, negative 3. Let me do one more, and this time I am going to let y equal, and I'll just pick something else. Let's say y is equal to 10, because you can really choose anything that you want to. If I let, not y equal to 10, but x equal to 10. If I let x equal 10, then I am going to put in y is equal to 2 times 10 minus 5. And I'm going to solve this. So I get y equals 20 minus 5, which means that y would be equal to 15. So another ordered pair that would work for this would be, if x is equal to 10, y would have to equal 15. Notice once again, there are all sorts of possible answers that you could give when you have two variable equations. One last thing to mention in this particular section. Given the equation x plus 2y is equal to 7, I do want to remind you that when you go through and you find possible solutions for this, and once again, I like to set up a t-chart and then change it to the coordinate pairs, you can have answers in which you are going to have fractions. For instance, for this particular one, if I say x is equal to 0, I need to replace 0 with the x in that original equation. When I do that, instead of writing an x, I'm going to have 0. I have 0 plus 2y is equal to 7. And then if I just want to solve that for y, I have 2y is equal to 7. I would divide both sides by 2, and that means that I would have y is equal to 7 halves. So I have y is equal to 7 halves for an answer for y. And you can certainly have that. if I let x equal 1 and put in 1 for the x in that original equation, x plus 2y is equal to 7, then I'm going to have 1 plus 2y is equal to 7. If I subtract 1 from both sides, I would end up with 2y is equal to 6. And then, going through and dividing both sides by 2, I get y is equal to 3. So another ordered pair does not have fractions, because the ordered pair 1, 3 also works. So just remember that as you're doing this, sometimes as you go through and you pick your own numbers, you might end up with fractions. Finding possible answers to two-variable equations is a very important skill as we progress through Chapter 6 in the book. Please remember that as you go through the problems, there are an infinite number of possible answers, though, so you're